Question 6th. A capacitor C is charged so that the potential difference V across its terminal is 8 volt. The capacitor is connected to the circuit. The switch is initially open. The switch is closed at time t is equal to 0. So this means the capacitor start discharging at time t is equal to 0. A part figure shows the variation of V with the charge Q on the plates of capacitor as the capacitor discharges. And we have to show that the energy stored in capacitor C at time t is equal to 0 is 1.8 millijoule. Now we know that energy stored in a capacitor is given as E is equal to half of QV. Now at time t is equal to 0, charge is this and this value will be, here are 10 divisions for 200. So 20, 40 and 450. So here charge is 450 microcoulomb, that is 10 raised to power minus 6, and potential is 8 volt. So on solving we will get that 1.8 into 10 raised to power minus 3 joule, or you can write 1.8 millijoule. Let's move on next question. Second part, determine the capacitance of capacitor C. Give a unit with your answer. We know that capacitance C is the ratio of Q to V. Now we have to find this ratio, and Q to V will be one of the, here if we see gradient of this graph is equal to delta V by delta Q. So 1 by gradient will be delta Q by delta V, that is equal to capacitance C. So it will be 450 divided by 8. 450 microcoulomb divided by 8. So capacitance C is equal to 450 into 10 raised to power minus 6 divided by 8, and it will be equal to 5.6 into 10 raised to power minus 6, that is magnitude, and unit for capacitance is farad and we denote it as F. Now B part, figure shows the variation with T of minus of log natural V by 8.0 V. So graph is given, on y-axis it is minus log natural V by 8.0 V, and on x-axis time is given. Show that when time t is equal 1 time constant, and we know that time constant is given as RC, where R is resistance and C is capacitance, then the value of minus log natural V is equal to 1. So we can start this with the relation. We know that variation of V with time is given as V is equal to V naught exponential minus T by RC, where T is the time, instantaneous time. So we can write V by V naught is equal to exponential minus T by RC, or log natural V by V naught is equal to minus T by RC, or minus of log natural V by V naught is equal minus T by RC. Now here we are having V naught, that is maximum or peak voltage 8 volts. So we can write minus of log natural V by 8.0 volt is equal minus T by RC, and T is equal to RC itself, so it will be RC by RC. So minus log natural V by 8.0 volt is equal to 1.0. This we need to prove. We will not write minus sign because negative sign I have already shifted here. Now move on second question. Determine the time constant T of the circuit. Time constant tau, we know it is given as tau is equal to RC, and if I compare this equation, tau is equal to RC, from this equation a graph is given between minus log natural V by 8.0 V versus tau. So if I compare this with y is equal to mx equation, then I can say y here is minus log natural v by 8.0 v is equal m into 1 by m into t. So here slope is given as, from this equation you can see slope is given as 1 by rc. So time constant tau will be equal to 1 by gradient of this graph, and gradient of this graph will be equal to minus 0 divided by, and here it will be 6.4, 6.4, that is 1 by 3.2. Substituting this value here, we can write tau is equal to 6.4 by 2, and that is equal to 3.2. So time constant will be 3.2 seconds. Third question is calculate the resistance of resistor. Now time constant tau is equal to RC, so resistance will be equal to tau by C capacitance. Tau we have calculated in above part 3.2, and capacitance we have calculated here 5.6 into 10 raised to power minus 6. So resistance will be 3.2 divided by 5.6 into 10 raised to power minus 6, that is equal 5.7 into 10 raised to power 4. Resistance is 5.7 into 10 raised to power 4 ohm. Now move on question number 7. A Hall probe containing a thin slice of semiconducting material is placed in a uniform magnetic field of flux density B. Largest face of the slice are perpendicular to the magnetic field. Magnetic field is in this direction. Current is in this direction. Okay. So value of current is given 5.4, and thickness of slab is 1.8 mm, that is x is given. Okay, now this is given, this is equal to I, and x is given 1.8 mm. So number density of charge carriers, this is n is also given. Constant current I value is given. Hall voltage Vh is developed between the terminals. Figure show variation with time t of B. Magnetic field versus time graph is given. Show that when B is equal to 4 into 10 raised to power minus 6 Tesla, the magnitude of Vh is 5.0 volt. So we know that Hall voltage Vh is given as Bi by Nte, or you can say B here is magnetic field intensity, I is current, this is B is magnetic field intensity, I here is current, E here is electronic charge, T here is thickness of slab, and N here is number density of charge carriers. Now we have to substitute these values, all values are given. So Vh will be equal to 4.0 into 10 raised to power minus 6 multiplied by current is given 5.4 divided by charge density is given here, let me check, 1.5 into 10 raised to power 16 meter cube. So it is 1.5 into 10 raised to power 16 multiplied by thickness is given 1.8 mm. So it will be 1.8 into 10 raised to power minus 3 meter, and charge on an electron is 1.6 into 10 raised to power minus 19. On solving this, we will get 5.0 volts. So this is Hall voltage. Second part is on figure 7.3. Sketch the variation of VH with t between time t is equal to 0 and 0.080 second. From this graph we can see variation of B versus T, and from this equation we can conclude that VH is proportional to B. So in this graph from 0.02 to 0.04 second, B is remaining constant, and another quantities I and TE are constant here. So VH will remain constant for 0.02 to 0.04, and then from this value 0.05 to 0.08 again VH is going to be constant value. Now we have to find the magnitude of VH also. Here when the magnetic field is 4, then we have calculated magnitude of VH is equal to 5.0 volts. So on our graph it will be here. From here this will be this will be 5 volt. So from this 0.02 to 0.04, the graph will be a straight line like this, and then from 0.05 to 0.08, here you can see magnetic field intensity is halved. So as VH is proportional to B, so VH will also be halved, and VH will be, earlier it was 5, so VH will be 2.5. So it will remain constant from 0.05 to 0.08, and value will be 2.5. So let me mark 2.5. This is 2, and this will be 2.2. This will be 2.4, and somewhere here like 2.5 will be here. So this one. So this will be a straight graph like this. So from region if I join, I'll join like this, straight line, then again straight line like this. Wait, I have to join these 2 points. So this will be the graph. Let's move on next question. B part. The Hall probe in A is replaced with a small flat coil that has 3000 turns. The cross sectional area is given. Number of turns are given 3000. Cross sectional area is given, that is A is given. Plane of the coil is perpendicular to magnetic field. The plane of the coil is perpendicular to the magnetic field. The electromotive force induced between the terminal of the coil is recorded as B, as shown in figure 3. The plane of the coil is perpendicular to magnetic field. EMF induced between the terminal is recorded as B, varies as shown in figure 7.2. Show that the magnitude of E at time t is equal to 0.010 second is 2 into 10 raised to power minus 4. Now we know that EMF is given as d phi by dt, where phi is the magnetic flux and phi is equal to NBA. I am considering NBA only because plane of the coil is perpendicular to the magnetic field, and if plane of the coil is perpendicular to the magnetic field, then theta here will be 0 degree. As we know, phi is given as BA cos theta. Suppose that there is a coil like this, and this is magnetic field, and if the coil is perpendicular to magnetic field, then the area vector will be parallel to magnetic field, and theta here is the angle between area vector and magnetic field. So theta will be 0 degree and cos 0 degree is equal to 1. So here we can write phi is equal to NBA, and E will become, therefore N will be constant, A will be constant, so it will vary with B. So dB by dt. Now at time t is equal to 0.010 second, at time t 0.010 second, so 0.010 second is this. At this time the magnetic field is 2 into 10 raised to power minus 6 Tesla. So it will be E is equal, E will be equal to 3000 into 3.4 into 10 raised to power minus 4 area, number of turns, and in time 0.010 second magnetic field has changed by this amount, 2 into 10 raised to power minus 6 second. This value I have taken from graph 7.2 figure. I have taken this value. So on solving this we will get 2.0 into 10 raised to power minus 4 volt. Now second question, on figure 7.4 sketch the variation of E with time t between 0 to 0.080 second. Now as from this equation we can see E is varying as the E is varying with dB. So dB by dt is the slope of this graph. So gradient of this graph is dB by dt, and E is varying with dB by dt. That is, slope of this graph will be the graph for E versus T. Now from 0.02 second to 0.04 and then 0.05 to 0.08, we can see the slope is 0. Therefore EMF will be 0. So graph from here 0.02 to 0.04, it will be 0. Then from 0.05 to 0.06 it will be 0, and magnitude of E is 2.0 into 10 raised to 1 minus 4 volt at time t is equal to 0.010. So at 0.010 the magnitude is given 2. But since E is equal to minus of d phi by dt, as per Lenz's law, negative sign here represent that induced EMF opposes the cause. So it will be negative. So magnitude is 2. So here it will be minus of 2. So 0. Yeah, this one. Wait. Yes, from 0 to 0.02 we can see the gradient is same. So yeah, till 0.02 the magnitude will be 2. So the graph will be like this, 0.02, and here then from 0.04 to 0.06, 0.04 to 0.06, sorry, now from 0.04 to 0.05 we can see slope again is same, again slope is same, magnitude of slope is same, that is 4 minus 2 divided by 4 minus 2 divided by 0.01, that is 2 by 0.01, and here it will be 10 raised to power minus 6 also, so it will be 2 into 10 raised to power minus 4. But since here the gradient is already negative, since gradient is already negative, so here the magnitude is negative, so EMF will be positive here, and it will become like this. So this will be the graph. Let's move on next question. Question number 8. Question A part. State what is meant by a photon. So photon, when we talk about any electromagnetic radiation, we know that all the electromagnetic radiations carry energy. So they carry energy in the form of photons. So photons are photons are packets of energy of electromagnetic radiation. B part. When the surface of a metal plate is illuminated with electromagnetic radiation, electrons are sometimes emitted from the metal. State the name of this phenomena. So if this is a metal plate and if any electromagnetic radiation of frequency h mu is incident, then sometime the free electron absorbs some part of energy and it gets liberated from the surface and it start moving with some kinetic energy Ke. So this phenomena is known as photoelectric effect. Photoelectric effect. Photo here means associated with any radiation, and electric means due to radiation electrons are being emitted from the surface. Second question. It is observed that this phenomena occurs only when the frequency of the electromagnetic radiation is greater than a certain minimum value, regardless of the intensity of the radiation. Explain how this observation provides evidence for the existence of photons. Now we know that uh, there is a frequency we say that is threshold frequency, and if the incident radiation is having frequency greater than threshold frequency, only then that radiation will be able to eject the electrons from the surface, because the free electron is loosely bound to the surface, and to liberate the electron we should supply a suitable amount of energy that is known as work function. Only then it will be liberated. Now if the incident radiation is less than that energy, then electron would not be able to move. You can write for this question that electrons needs a minimum energy to escape, and the energy must be absorbed in packets. Packets here we are referring to photons that are related to frequency. Intensity relates to number of packets. So when we increase intensity, we just increase the number of photons emitted by the particular source. So intensity will just increase the number of photons, it will not increase the frequency, or you can say it will not increase the energy. So intensity is related to number of packets only, not to energy. Therefore, it absorbs only a single whole packet. Now C part, the figure show variation of maximum kinetic energy versus frequency. Maximum kinetic energy versus frequency graph is given and state the name of quantity represented by gradient of the line. Okay. We know that if there is a metal surface and if energy of photon incident is h mu and here is an electron, free electron, then this electron will absorb some amount of energy that is equal to work function of the metal, and rest of the energy will become the kinetic energy of the electron, that is Ke max, because maximum kinetic energy here we are considering, because we consider maximum kinetic energy because all the electrons are initially having different amount of energies. So when the photon of energy h mu is incident, then work function is same throughout the metal, but the kinetic energy gained will be different. So equation we can write h mu is equal to kinetic energy max plus work function, that is phi. Now if I rearrange this equation, so I can write Ke max is equal to h mu minus phi. Now we can compare this equation with y is equal to mx plus c. So on y axis kinetic energy is there and on x axis frequency is there. So here slope will be equal to h, and what is h here? H here is Planck's constant. So the gradient of the line represents Planck's constant. And y-intercept of the extrapolated line from y-intercept c here is equal to minus phi, and phi is the work function, so y-intercept give negative of the work function. Let's move on next question, question number 9th. Fluorine 18 is a radioactive nuclide that is used as a tracer in positron emission tomography. Fluorine 18 decays to a nuclide of oxygen according to the equation is given. State what is meant by a tracer. So in PET scanning, what we do, in PET scanning, a radioactive nuclide is inserted inside the body of a patient, and that radioactive nuclide is absorbed by the organs, or we can say the tissues of the body, and then radiations from this is used to produce the image in PET scanning. So what is tracer? So tracer is a material, it is a material injected into the body and is absorbed by organs and tissues, and radiation from this is used to produce image. Now second question, state the symbol of the particle that is represented by XPQR. We know that fluorine decays by beta emission. It decays by beta emission. So, and what type of beta particle it is? This is positive beta particle, beta plus particle. So here it will be beta positive. Now P, what will be P? So P here will be 1 because beta particle we can represent it as 1 and 0. So Q will be 0 and R will be, if Q is 0, so according to law of conservation of the mass, if 18 is here and Q is 0, so R should be equal to 18. Okay. B part. So question here is, explain how the radioactive decay of fluorine 18 results in the emission from the body of the gamma ray photons that are detected during a PET scan. So what happens during a PET scan? As we have seen in above example that a beta particle is emitted when fluorine 18 decays. Then when this beta particle is emitted, then that beta particle, or that beta particle I can say that is positron. So when this positron moves through the body, it encounters an electron, and beta particle or positron is the antiparticle of the electron. So whenever this particle and antiparticle meet, this is known as annihilation. This is known as annihilation. And in annihilation, what happens? The electron plus beta, electron is a particle, beta positive particle is a particle. Both are having mass, but when they combine or they annihilate, this mass is converted into energy in the form of gamma ray photons. So, this is how gamma ray photons are detected during a PET scan. So, you can write the positron moves through patient's tissues, encounters an electron, the pair annihilate and their mass becomes pure energy in form of two gamma ray photons. Next, second question, explain how the detection of gamma ray photons is used to produce an image of tissue being examined. So the two gamma ray photons, when they travel in opposite direction and they strike detector, but their arrival time is not same. There is difference between the arrival time, and due to this time difference, this data is processed and an image of tracer concentration in the tissue is created. And wherever the more photons arrive per unit time, then that point appear as bright point. So you can write gamma ray photons travel in opposite direction and strikes detector, where the more photons arriving per unit time, it will appear as a bright point on image, and image of tracer concentration in the tissue can be created by processing the arrival times of gamma ray photons. C part, the half-life of fluorine-18 is T. A patient is injected with the amount of substance N of fluorine-18. And determine an expression for initial value R naught of the rate of production of gamma ray photons by tracer in terms of NT and Na. We have to find the rate of production of gamma rays. Now gamma rays photons are produced when fluorine 18 decays. So we can say the decay rate of fluorine will be the rate of production of gamma rays. Decay rate or decay per unit time, decay per unit time is given as A is equal to lambda n, where n is the number of nuclei. So number of nuclei can be written as A is equal to lambda, that is amount of substance multiplied by the Avogadro number Na, and we know that lambda is equal to log natural 2 by T, where T is the half life period. So we can write that R naught, that is initial value R naught of rate of production, is equal to 2 into lambda into n into Na. Here we have multiplied by 2 because 2 photons are produced in each decay. So R naught can be written as 2 into log natural 2 by T into N into Na. So R naught will be 2 N Na divided by T into log natural 2. Next question. Second question, sketch the variation with time T of R. Y axis it is R and on x axis it is time T, which is half life. We know that after half life the sample becomes half, or rate of decay will become half, or rate of production of gamma ray will also become half. So at time T the rate it will become R naught by 2. Another half life, that is after time at this point the rate again will become half and it will become R naught by 4. So this point will become R naught by 4. So graph will be like this. Next question. State Wien's displacement law. Identify any symbols that you use. So we know that Wien's displacement law is given as lambda max T is equal to constant, where lambda max is wavelength at which maximum emission rate occurs, and T is thermodynamic temperature. Or you can also say that as per Wien's displacement law, lambda max is inversely proportional to temperature. B part. A cosmology student observed the electromagnetic radiation received from a star in a galaxy. The student uses Wien's law to estimate the surface temperature, a standard candle to estimate distance, and Stefan Boltzmann law to estimate the radius. Student observed that the radiation from the star is redshifted. State what is meant by a standard candle. So standard candle is an astronomical object of known luminosity. Next, second question. State the reason why the radiation from the star is redshifted. So we know that redshifted means there is increase in wavelength, because red color has more wavelength, and increase in wavelength means there is decrease in frequency. And as per Doppler's effect or Doppler's law, the decrease in frequency is when a source of radiation is moving away from the observer. So here we can write in answer that star is moving away from the observer. Question: the true values of quantities observed or estimated are those that are corrected to allow for redshift. However, the student doesn't correct for redshift. Placing one tick in each row complete table indicate how the observations and estimates made by student compare with the true values. So wavelength of radiation will be too high, and the surface temperature will be too low, because we know that Stefan Boltzmann law lambda max is inversely proportional to temperature. Now, since we have considered now distance to star, what will happen to the distance? Since we have considered a standard candle, and we know that standard candle, the luminosity is known, that is, and F is equal to L by 4 pi d square. So F is constant, L is constant, so D will also be constant here. So distance to star will be same, and radius of star, for calculating radius of star, we can use Stefan Boltzmann law, that is L is equal to 4 pi sigma square r square T4. Now this is constant, here it is constant, sigma square is constant, so r square is inversely proportional to temperature raised to power 4. So temperature is too low, therefore radius of star will be too high.